Lab Guy here. I've got a long video today, March 9th, 2021. I've been busy. As you can see, it's been a while since the video before last. The weekly updates generally come at 9-10 days apart. And as I've mentioned, I don't like giving you update videos. I want to do project videos, and today we are back on the 6104 Craig video camera. So we will be getting into that shortly. One of the things that took up most of last week was the beginning of the cleanup of my storage lockers. I have 3 storage lockers that are costing me the cost of health insurance. So that's a lot of money for somebody my age. I would rather have that money going into my college fund. So I'm going to be reducing my inventory heavily. So look closely at the following video. And if you see anything in there, you can reach me through my website, www.labguysworld.com. So here, without further ado, is the look at my storage unit cleanout. Here we are today at my storage unit, where I am going to be getting rid of tons and tons of crap. It is stacked up in the back. That pile back there is at least 10 feet high, up against the back wall, and extends down this side. And it's cameras, personal items, videotape recorders, files, just tons and tons of crap. I've been concentrating some Cartravision stuff over here for a friend of mine. And we have camera, cameras, 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 camera, camcorder, camera, video editor, useless. The electronics for it are somewhere buried over here, I think right down in there. Camera, cameras, monitor, camera, back there in the dark, monitors, just tons of crap, more crap. And did I mention the crap? Lab Guy's nightmare will be continued. As you saw, there is a lot of crap in my storage locker. There are cameras, there are tape recorders, there are video switchers, and cables and parts and tapes. I have EIAJ reel-to-reel tape running out of my ears. If you need some 7-inch or 5-inch rolls of half-inch videotape, let me know. I can fix you up. Many of them, in fact almost all of them, are pre-recorded with content which you can use for testing your video tape recorders. So, enough about that. I have been working on the Craig 6104 camera and making great progress. I don't have the full schematic traced out yet, but I probably have a solid 88%, maybe in the high 90% actually. And we are getting there. I have shot a lot of video during the process. I don't know, but I'm going to try to edit for you a coherent program that is not about the 6104 camera per se, but about the process I'm using in order to reverse engineer this camera. Many of you out there may get an old antique electronic item. It could be a stereo amplifier, a television, a tape recorder, or a TV camera from the periods of the 50s, 60s, and 70s, and you will not have service information or not know how to get service information. And in that case, you're going to have to produce it yourself. This video is going to be watch over my shoulder as I do that process, and you will see how I do it. Is this the right way to do it? Is this the best way to do it? I don't know. It's the way I do it. So let's get on with that, and we will now get into the into several sections where I've been working on the camera. I don't even know how much video I have. It's several hours, which I will try to condense into about 20 to 30 minutes for you. So enjoy the following video. Over here is this round socket connector. Again, you can't see it. Dang. Okay, this is the 9-pin socket that's on the board, and we'll have to go from there. We've so far got the horizontal scan circuit pretty much complete, and now I will be putting in the vertical scanning circuit. So we'll just start by copying and pasting components that I see on the schematic that I will need. A 20, oh, that's the 22K also. Copy. Okay. I wonder. That's fine. Pin 5, 6, 7. Okay. That one goes to pin 8. J2 8. Wow. Bizarre. Diodes are D2 and D3. Edit. D1. Copy. Okay, so of Q1 collector, really? Collector of Q1 went to a 10 microfarad, it went to a 471 PE. to a 10K to ground. 10K. 10K to ground. Oh, shoot. There we go. Yeah. Yes. This diode, these two diodes are forming an OR gate where we're bringing in blanking pulses and combining them, this side being the horizontal signal, this side comes from the vertical circuit. I'm not wiring him in yet because he's probably going to point that way. Let's just start. Initially, as I put these circuits in, they're spaghetti because I'm not sure what they are until I've drafted them out. So put my eyes back on. Alrighty then. So he goes to ground through a 10K. He's got a capacitor coupling in. Okay. He's pulled up. His collector goes to ground, so he's probably a PNP. Edit Q5. Q6. The emitter goes to ground. Collector, emitter, 100 ohms to ground. Okay, so copy. Okay, and this is Q6. And we have a 100 ohm coming off of that. Handy already labeled 100? No big deal. Let's copy this one. Copy. Edit. 100 ohms. And he's got a whole bunch of capacitors attached to it. This is not fun. Let me tell you, it's not fun. Don't know if you can see it. We're not white balanced for this, but not fun. Okay. Check back with you later. Yeah. Q4 to 268A. Edit. 268A. Okay. So Q5 2SC538. 2SC538A. Q6 2SC538A. Nope. 2SC538A. Q7 isn't on here yet. Q11. Out of sequence number, but that's life. Okay, so let's see what we got. We got the 100 ohm coming off of there, coming down to the collector of Q6. 3.3K up to there. We have a the hell is going on there? Wow. It's got to be a DC power line. Okay. That's going to all of those things. Okay, 3.3K. From the base of Q5, we've got that. And then we have, let's see, 820, so that's a PNP, 2SA385, Q11. It's a PNP. Dang it. Okay. 2SA385. 2SA385. Q11. Okay. So we have a 10K coming from this node here. 10K going to the emitter of that. I have a feeling that all of this circuitry is going, I've got it oriented going in the wrong direction, but I don't know yet. So yeah, I think I'm dealing with a circuit that's going completely backwards. I figured out that this section is a current source. So, wow. Now I gotta flip that sucker around. Okay, I'm gonna have to deal with this. Huh. Nice. Okay. Move, delete, okay, move, and that figures. Okay, move, from there, there. There we go. Alrighty then. Now, this guy, Q11, oh god dang it. Okay. Is there anything on Q6's emitter? Just the resistor. Okay. Right. Okay. Right. Okay. Move this whole thing over. So this circuit is a current source. I have no idea what this is doing yet. Okay. But it's not all done yet. The base of this guy, okay, maybe the collector is more important on him. Okay, Q11's emitter goes up through a 1.5K. Okay. Goes to there. Huh. It's in parallel. We still want to lift those two up. I'm not sure this is right, but we'll see. Okay. And the 1.5K goes like that. And we are going to begin buzzing out the connections from the main power transformer through the rectifier filter board and determine the various voltages. But the first thing I need to do is disconnect the what appears to be the low voltage and high voltage secondaries, which may or may not have a common center tap. Now this is not uncommon in the time period. So we're going to disconnect those first. So here goes. That was easy. Okay, we have the two orange wires disconnected. So we're going to disconnect all of them except the black wire, which is ground. I've already determined that. We're going to buzz out these orange wires, and we're going to determine if they're connected to the other wires. We know they should be common with each other. 19.4 ohms. There we go. Alright. We'll call it 20 ohms. 9.6 ohms to the black wire. There we go. 9.9 ohms to the black wire. 19 ohms between them. There's 2,100 ohms. 1,548 ohms between the blue and the green wire. 2,000 ohms to the black wire. 560 ohms to the black wire. 1,500 between green and blue. And 2,000 from green to black. 2,000, 1,500, and 500. It's grounded at the bottom. The first tap is 500 ohms and the second tap is 2,000. So I'm connecting the meter to the center tap of the transformer, which is chassis ground. So we'll go back to ohms real quick, and it is chassis ground. Alright, AC volts. We'll start with the center tap wires, the low voltage center tapped pair. Okay, now our chance of electrocution has increased. All right, 20.6 volts on one of the orange wires, open circuit. And 20.6. Alright, we'll reconnect them and measure them with the load. Alright, now reconnected. Watch out for that green and that blue, because I bet they bite. Under load, 20.6. We're going to look at the blue wire next. Alrighty, everything is off. We'll do the blue wire next. And the blue wire is 98.5 volts. We'll call it 100 volts. And the green wire is probably going to be a mama that will bite you bad. 100 volts will sting. Okay, here's the green wire. Oh, wow. My meter does not even like that. What is going on? Do we have a bad connection? Fascinating. Well, the meter is good up to 1,000 volts. Now let's go from the blue wire, take off 100 volts. That's very odd. 270 volts or so, and it would be 370 above ground. Should be no reason why the meter cannot measure to that. Here we go. Boy, we are all over the map. What the hell? Perhaps this transformer is open. No, that's very odd. Volts AC. We are connected correctly. Huh. How odd. This is not good. Alright, about 270. It's all over the map. I mean, the meter isn't loading it down that I know of. Alright, so that would be 370 volts. So there it was, the Craig 6104 reverse engineering process up to this point. I hope you've enjoyed it. I really hope you learned something. Maybe you learned, I think I'm going to collect butterflies instead. Something that may not take up so much space, time, and money. You know, Einstein did connect space and time, but he never proved that time is money. But trust Lab Guy, time is money. Money takes time. So there you have it, the wisdom from the old fart. So until next time, Lab Guy out.